Hi statistics students, I want to go over using your calculator to try one proportion hypothesis testing. So let me pull up some problems. I'm going to start off with the first question on your homework for section 6.3. There were 2,430 Major League Baseball games played in 2009. The home team won 54.9%, so 54.9% of the games. If we consider the games played in 2009 as a sample of all the games, see if there is evidence at the 1% level that the home team wins more than half the games. So first of all, we need to set up the hypothesis test. So this first one looks great. We've got an equal sign and more than. Now, why do we need the hypothesis test if we're going to be using the calculator? Well, you need to know the direction that you're going in. So let me pull up the calculator. Okay, so come over here to Stat and Test. And what we're looking for is a 1 proportion z-test. I say enter. So P0, that's the null hypothesis, 0.5. And we need to know how many they won. So I'm seeing 0.549% times the 2430. I'm going to probably have to round that number, so I think I'll just throw off that 0.7. So 1334. 1334 out of 2430 games. And right here, this is where our alternative hypothesis comes in. We want the greater than. Right there. So I'm just going to hit enter to select it. Now I can draw it or I can calculate. Let me show you the draw because I think that's pretty cool. Draw shows a normal curve. It shows the z statistic right here and the p-value right here. And it says, basically you're off the scale. Now if we went back to calculate, so stat, test, that was what, number 5? I just hit 5. And come down and use calculate, then I get the same thing. It tells me that the alternative was greater than half. Here's my z value. The p value right here is, boy, that's 0.0, I gotta count my fingers, 0.0000069, and then the p hat was 0.54 and then 9. And here's our sample size. So that's how you can use a 1 proportion z-test with section 6.3. I'm going to show you one more example. Okay, so multiple choice questions on an AP test have 5 options: A, B, C, D, and E. A random sample of the correct choice on 400 multiple choice questions show that B was the most common choice, or correct choice, sorry, with 90 having B. Does this provide evidence that B is more likely to be the correct choice than would be expected if all 5 options were equally likely? Okay, again, we need to set up the hypothesis test before we actually start throwing things out there. So when we have 5 choices, the proportion is going to be 20%. And now we think the proportion is going to be greater than 20%, because that's what we need to test right here. So we need a test statistic and a p-value. Let me pull up the calculator. Turn it on. I'll clear that out. Okay, so stat, test, I'm just going to hit 5. We're testing that the proportion is 0.2, and we know that 90 out of 400, let me just come back up here and check. Yeah, 90 out of 400. Oops, bring my calculator back up. And, okay, we can still keep the same one. If I do draw. Okay, now this one, I don't think I'm going to be rejecting the null hypothesis. I mean, look at that, z, 1.25, and we've got this edge shaded in. So it's just like stat key right here. So I just go ahead and put in 1.25 and my p-value was, calculator, where are you? 0.1056, 2 decimal places. Can we conclude B is more likely to be the correct choice? Well, I cannot reject the null hypothesis. I will fail to reject the null hypothesis right here, which fails to provide enough evidence to support the alternative. So no, I can't conclude that B is more likely to be the correct choice. So that's how you can use your calculator for section 6.3.